Hello. So today we are going to be focusing on the um, atomic structure unit, the concept 4 here. So going on to atomic mass units and then calculating atomic mass. So this one will definitely take some more calculation as far as like calculator wise goes. So just make sure that you either have a quick access to one on your phone or iPad or some other way. Our goal for today is to calculate the atomic mass. When we were given percentage abundances that have to do with the atomic masses of isotopes. So I think I had mentioned before that we're going to come back to isotopes eventually, and today is when we're doing that. And so with the isotopes, we're also going to compare the relative abundance of isotopes for particular elements. So let's just kind of remind ourselves what an isotope actually is. So remember that the mass number, which is a rounded number that we usually use because we just take the atomic mass and we round it. So that number, the mass number, is our number of protons plus our number of neutrons. But remember that all atoms have isotopes for them. So these are atoms, still the same type of atom, but they have a different number of neutrons, either more or less than like the main one. And what that will do is it will throw off your average. It throws off your total mass because some elements or atoms are heavier and some are lighter. And so you have to do an average of those. So atomic masses occur with decimal points because they're an average of those different isotopes. And isotopes just are there because I think, we have natural variability. Not every single one is the same. Some of them, some atoms, again, are able to hold on to those couple extra neutrons and not have it affected any. So the number of isotopes or the number of neutrons is going to vary between atoms. So AMU is short for atomic mass units. Now, an atomic mass unit has to do with carbon, and carbon was one of those atoms that we have long had identified, and so this is why carbon was kind of used as sort of the starting point here. One atomic mass unit is defined as being 1/12 of the mass of a carbon atom. Because we knew that carbon was about 12, and so 1/12 is about 1, and that's kind of where that comes from. But this is the way the atomic mass is measured on the periodic table, and again, abbreviated AMU. Really, atomic mass is just 1/12, which is just basically 1. But that's kind of where our starting point that is sort of used for that. So to find the atomic mass, you'll need to know the number of stable isotopes. And so the number of isotopes can vary anywhere from 2 to 3 to 4 to maybe even 5. Again, the word stable is sort of the key word there because there are some, we're going to do a lab here soon where you guys are going to be kind of playing around with isotopes and with different like adding in numbers of protons and neutrons and things like that, and you'll be able to see that that you'll get to a point where you can add in too many neutrons or take out too many neutrons, and it'll become unstable. So there's only usually a number of stable isotopes, so it's not indefinite. You can't just like add like 30 different, have 30 different isotopes. There is a limit. You need to know the mass of each of those isotopes, and so it's fairly easy because it's just the proton number, which is always the same, and then the number of the neutrons, which is just 1, is what we're going to come up with, and then the natural percent abundance of each of those isotopes. So again, how many isotopes do you have? What's the mass of each one? And then how abundant are those isotopes? Abundance meaning like how common are they? Some isotopes are like pretty even, like among them, like maybe like, each one is about like 30% in nature if you have 3 of them. And then some of them are like way more one-sided. Like one of them is like 95% that, out of, 100 atoms that you randomly were to look at, 95% of them would be, one isotope. So it just really depends on the example. All right, so we're going to be using this term called weighted averages. And before, a couple years ago, you guys might not have had experience with weighted grades or weighted averages. But now that you've been in the grading scale that we've been using for the last few years, you should be a little bit more familiar with this. So as you know, in class or in our for your grade, your percentage for your final calculated grade is about 90% what we call summative work. That would be tests, quizzes, things like that, lab questions sometimes I'll put in there, projects, anything like that that is more heavily weighted goes there under that 90%. And then homework, practice, things like that are on that 10%. If you go into colleges, or once you guys, probably go to college, you'll see probably some a little bit more broken down categories. I used to use this as when I taught at a different school, something similar to this, and this is probably something that you might see. So in colleges, every professor has their own kind of weighted grading scale, but I think almost all of them use weighted grading scales. So tests make up about 70% of your grade. In the past, when I taught at different schools, I would usually make tests about 40-50% of the grade, but this is just an example. Quizzes make up about 20% of your grade. So if you're looking at this, you have 70 plus 20, that gives you right away 90. So you only have 10% left to work with here. And so in this case, that's about homework. Okay, so this is similar to our grading scale at school, except we kind of combine the tests and quizzes one into one category. We just have 2 categories. This example has 3 categories. So this could be just like the number of isotopes. So we could have isotope number 1 is about 70% of abundance. Isotope number 2 is about 20% of the abundance, and isotope number 3 is about 10% of the abundance. So that's how we're kind of looking at it. But here's if we kind of keep following this is what you would look for as far as your grades. So let's say on a test you get 80. All right. On quizzes you get about 100. And on homework, you get 100. All right. So this is like 80%. So, you're not necessarily 80 points, or maybe it is points. It doesn't really matter here in this case. But so test is 80, quiz is 100, homework's 100. So to find the weighted average, you take your 0.7, which is the 70%, times your score for your test, which was 80. And then you add your 0.2%, or the 20%, I should say, times the 100 that you got on your tests. And then the last one, you add in the 0.1 times the 100. So here's what you get. You get 56 once you times those two together, plus 20 plus 10, and you get an average of 86%. So even though you scored 100% on the quizzes and 100% on the homework, your final score is still only at 86% because your test grades are weighted more heavily because they take up 70% of your grade. You have to make sure that all those percentages add up to 100, otherwise it won't work. So 0.7, 0.2, 0.1, all of those added up to 100%. Okay, so when we, this is the end of what you guys have in your packet. However, I am missing a page from here. Like, I'm looking at your packets, and there's actually a page that got that did not get copied, and so I'm going to have a printout of all of that missing page for you guys to staple into your packets, and then for the rest of you, if you're still at home, I'll have a copy of that one sent to you just electronically. So let me show you what I'm talking about here. So this was the page that you just filled out right here. And then it goes right to the worksheet number 4, but there is another page that goes in between numbers 15 and 16. There should be another page of notes that we have to take. So since we don't have that, the only other thing I want you to do, and I think I might have mentioned this in class already, was to move ahead and do this pre-lab for build an atom. So some of you might have this done already if there was time in class. I think I may have given you time to do this. So number 1 says you build an atom that has the following components: 3 protons, 4 neutrons, 3 electrons. So I want you to draw that in here. Make sure that you put your atoms or your subatomic particles in the right location. So in the middle, you should have 3 protons. Make sure you put P's in there so I can tell that those are the protons. And then 4 neutrons, those should also go in the middle. And then your electron should be along, somewhere around the outside. And then for you're going to circle the element on the periodic table that example matches up with. So which one of these is it? And then you're going to figure out the mass of the atom that you drew and explain what you used to use your answer. Figure out the charge of that atom based on your number of protons and electrons. Same idea here. You start with your atom: 3 protons, 4 neutrons, 3 electrons, and then make sure you answer these questions here. So mark yes if a change will work, mark no if it will not. So you're looking here at this one right here. So hydrogen, helium, lithium, beryllium, boron all are different elements. If you want to change the type of element your atom is, you can either, so if you change the type of element, if you add a proton, will that change it? Yes or no? If you add a neutron, will it change the type of element you have? Yes or no? If you add an electron, will it change the type of element you have? Yes or no? These are pre-lab questions, so whether or not you get them 100% right is not necessary. I just want you to try your best for these. So those are 2 pages that I would like you to have done as well. So let me just double check here. That is pages 21 and 22. So 21 and 22 is what I also want you to have done for tomorrow. All right. Thank you.